Hello, I'm Samantha Eldridge, and today I will be filming a video on the essential concept in mathematics and problem solving, logic statements, and quantifiers. These tools form the foundation of mathematical reasoning and help us create precise arguments and proofs. We'll cover what logic statements are, the basic type of quantifiers, and how these concepts are applied in the real world. To go over the overall idea, I would love to explain how this section is to understand how we use logic statements and quantifiers to express precise mathematical ideas. A logic statement is a sentence that is either true or false. Quantifiers allow us to make statements about groups of objects, which is essential for expressing generalizations or specific instances in math. For example, when we say all even numbers are divisible by 2, we're making a universal statement about all even numbers. When we say there exists a number that satisfies a certain equation, we're making an existential statement. So to go over the basic topics of statements and quantifiers, I would love to define logic statements as a declarative sentence that can be evaluated as either true or false. Examples of logic statements include 5 is greater than 3. That is obviously a true statement, so that is a logic statement. Another one is the sky is green. We know that the sky is not green, we know it is blue, so that is obviously false, which means it is also a logic statement. Questions or commands like what time is it or close the door are not statements because they do not have a truth value. They do not have a right and wrong associated with the answer of the question. For quantifiers, in mathematics, we often use quantifiers to describe statements, entire sets of numbers or objects. The two primary quantifiers are universal quantifiers and existential quantifiers. So, to go over our quantifiers, we have our universal quantifier, and it is defined by an upside down A. We know that the example is, this means for all or for every. An example is, for all integers n and n to the second, it is greater than or equal to 0. That is our example for a universal quantifier. This means that no matter which integer you pick, its square is always non-negative. For our existential quantifier, this means there exists or at least one. Example is, there exists a real number x such that x to the second equals 25. This means there is at least one x that satisfies the equation. Understanding these quantifiers helps us frame mathematical arguments more accurately. Now to understand the real-world applications of logic statements and quantifiers. Logic statements and quantifiers are not just theoretical concepts, they have many real-world applications. For one, computer science is one major topic where these concepts are used. In programming, logical statements and quantifiers are used in algorithms, conditions, and decision-making processes. For example, an algorithm might need to check if all elements in a list meet a condition, as a universal quantifier, or if at least one element meets a condition, as an existential quantifier. Now, according to another major topic of where these are used, is artificial intelligence. Many university and college students use these processes and programming ways of artificial intelligence that use logic statements and quantifiers to give us information. For instance, artificial intelligence systems rely on logical reasoning to make decisions. Statements and quantifiers help artificial intelligence determine outcomes based on data, such as identifying patterns or making predictions. Another real-life example is law or contracts. Legal language often uses precise statements to avoid ambiguity. For instance, a contract might state, all payments be made within 30 days, ensuring there is no misunderstanding about the requirement. And the last real-world example can be seen in science and research. Scientists use logic statements to form hypotheses and make conclusions. For example, all tested samples showed positive results is a universal statement that supports a research conclusion. By understanding logic and quantifiers, we can make more precise decisions, whether we're writing code, drafting a legal document or argument, or conducting scientific experiments. So, to conclude, in summary, logic statements and quantifiers are essential for expressing clear and precise ideas in mathematics and beyond. They help us form accurate arguments, prove theorems, and solve real-world problems. Whether you're in computer science, law, or science, these concepts are invaluable tools for clear thinking and problem solving. Thank you so much for watching, and I hope this helps you better understand the importance of logic statements and quantifiers. Have a great day.